In this lecture, we are going to explore virtual destructors. And these are destructor methods you might want to be called using dynamic binding or polymorphic behavior. We are going to be using this inheritance hierarchy to play with things. So the animal class is going to be our base class. We are going to derive from that publicly and have a feline class. And we are going to derive from feline and have a dog class. This is the setup we are going to be using here. Now, let's look at some code. We are going to set up our animal class like this. Nothing really special here. Notice that the destructor is a regular destructor we have. We will derive from animal and create a feline class, which is going to set up its own virtual function, which is going to be run. If you want, you can override the breathe method, but we don't want to do that here because we just want to focus on the destructors here and the order in which they are going to be called. We are going to derive from feline and set up a dog class. And this dog class is going to set up its own virtual function. And notice that it has a destructor, which is really a regular destructor. Now, once we have this inheritance hierarchy set up, we might want to do something like this. We can create a dog object. And when it is time for this object to be destroyed, I want you to focus on the order in which the destructors are going to be called. We have seen this before. The destructors are going to be called from the specialized to the most base implementation of the destructor. So the destructor for dog will be called first, then we will call the destructor for feline, then we will call the destructor for animal. Now, a problem is going to pop up if we are using a base pointer to manage a derived object with polymorphic behavior that we might want for our inheritance hierarchy here. So we are going to use an animal pointer to manage a dog object like this. And when it is time to release the memory for this object, we may be tempted to call the delete operator on our animal pointer here. But this is only going to call the destructor for the base class. And hopefully you can see the problem here. Because our destructors are not virtual, the compiler is going to use static binding to decide which destructor to call. So it is going to look at the type of our pointer. It is going to see that it is an animal pointer, and it is going to decide to call the destructor for animal here. That's why we get this result. We are managing an object which is not just an animal. It has derived information in it, but we are only calling the destructor for the base part of this thing. So any piece of dynamic memory we might have allocated in the constructors for feline or dog is going to be leaked out. Because remember, even if this is a dog object, it is made up of base parts. The foundation for this is going to be animal. And on top of that, we are going to build a feline level. And on top of that, we are going to build a dog level. In this case, only the destructor for dog is going to be called. And any dynamic memory that might have been allocated at the feline and dog level is going to be leaked out. And this is something we don't want. You really need to keep your eye out on this. And this is something really bad. You really need to keep your eye out for this. So this is a really big problem. And to solve it, we need the destructors to be called using polymorphism. And you can set that up by marking your destructors as virtual. If you do this, the compiler will know that if you are going through a base pointer to manage a derived object, when time comes for the memory to be released and you release the memory through a base pointer, the compiler is going to call the most specific destructor it can find. And this is going to solve our problem. Then we will reuse the order we are familiar with. The most derived destructor will be called, and it will call its base destructor, and that's going to happen until we hit the most base class in our inheritance hierarchy, and memory is going to be released exactly as we would want. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. We are going to learn about virtual destructors. And before we do that, we're going to grab our template files and put them in place. Let's do that. And I am going to put in the classes that make up our inheritance hierarchy. Our most base class is going to be base. Our most base class is going to be animal. After that, we're going to derive we are going to derive from that and create the feline class. And we are going to derive from feline and create a dog class here. This is the inheritance hierarchy we talked about in our slides. Okay, we are going to open this up in Visual Studio Code, and this is going to give us our classes here. And we are going to remove these virtual keywords because we want to see what would happen if you don't mark your destructors as virtual. We're going to do that for feline. We're going to do that for dog. Let's remove the virtual keyword here. We're going to remove that, and we're going to remove that for the animal class. And we want to see the implementations for our destructors. For animal, we are just going to say that the destructor for animal was called. For feline, we're going to say the same thing. Feline destructor called. For dog, we're going to say the same thing. We're going to say destructor for dog called here. We are using strings as our parameters here. So I think it is a good idea to change these guys to use string view. I am going to do that and come back when this is done. Okay, this is done. All our parameters are of std string view type. And now that we have this inheritance hierarchy, let's make sure none of the destructors is virtual. This is the case here. We can head over to the main CPP file and use this inheritance hierarchy here. We're going to crack it open and remove whatever we don't need here. We are going to include our dog class, which is going to implicitly include or its parent classes. So we're going to include dog.h here. And we are going to create a raw dog object by default here. We're going to say dog, and let's say dog1. We can do that. And we might not even give it any parameter. This is going to call the default constructor. And if we go to dog, we're going to see that it is possible to specify information here, first style, description, but we're going to ignore this. And we just want to see which order in which the destructors are called. Let's build and run this program. We're going to pass this through GCC. The build is going to be good. If we clear, let's bring up a PowerShell window to do that. We're going to clear and run Rooster. You're going to see that dog destructor was called, feline destructor was called, animal destructor was called, and this is really cool. This is the order we expect by default. But if we don't do something like this and say animal pointer and say p animal to mean a pointer to animal, and we say new dog, we're going to allocate a dog on the heap, and we're going to manage that using a base pointer. And if we try to release the memory here, let's do that. We're going to say delete p animal. Let's see which destructor gets called here, because notice we are using a base pointer to manage a most specific object here, which is a derived class of dog indirectly. And we will see that we don't get the destructors called in the order that we expect. Let's build and run this program to really see this. We're going to use GCC to build it. The build is going to be good, as you see here. We're going to clear and run Rooster. Now you see that only the destructor for animal is called, even if we are really managing a dog object. For things to work really well, we would expect the destructor for dog to be called, and then the destructor for feline, and then the destructor for animal to release or the memory that might have been allocated by these parent classes for our dog class. If you go back in the CPP file, for example, for each of these classes, you're going to see that the compiler is going to be calling each base class of the current level that we are at. In dog CPP, we are going to call the constructor for feline. The constructor for feline is going to be called if it is doing any dynamic memory allocation. We need to release this memory. Constructor for feline is also going to call the constructor for animal. And if animal is doing any dynamic memory allocation, this is going to need to be called. But notice that we are just calling the destructor for animal. And if we only call this destructor, or the memory that was allocated by the feline constructor is going to be leaked out because only the animal destructor is going to be called. Hopefully you can see the problem here. But this is not the only problem. The C++ standard says that if you do something like we are doing here and call a destructor using a pointer to the base class, but that pointer happens to be managing a derived object, this is going to give you undefined behavior. So you're not guaranteed to get the same behavior on different compilers, on different operating systems. So this is something really bad. We want all the destructors in our inheritance hierarchy to be called to properly release the memory that would potentially be dynamically allocated by each level in our constructor calls. The fix for this is really simple. All you have to do is mark your destructors as virtual, and the compiler will call the most specific destructor for your classes. So all we need to do is go in and mark these guys as virtual. So we're going to do that. The base class destructor is going to be marked as virtual. We're going to go to feline and do the same thing. We're going to mark that as virtual. And we're going to go to dog and mark its destructor as virtual. We're going to do something like this. And now notice we don't need to change any other thing. If we build our program, we're going to pass it through GCC. It is going to do exactly what we want, because now the compiler will resolve the calls to the destructors polymorphically. Because we are going through a base pointer, the compiler will call the most specific implementation for the destructor. Because we are going through a base pointer to call the destructor here, the compiler will call the most specialized destructor we can find. And it is going to find the destructor for dog, which is going to be the most specialized destructor we can find in our inheritance hierarchy. It is going to call the dog destructor. That's going to call the destructor for feline in turn. And then that's going to call the destructor for animal. And our memory is going to be released properly. That's what we're going to see here. Let's make sure we build this again, because I'm not sure if I actually built this. The build is going to be good anyway. So we're going to clear and run rooster. Now you see that the dog destructor is called, the feline destructor is called, the animal destructor is called, and everything is just going to fall in place. So my advice, if you are using virtual functions in your inheritance hierarchy, make sure you also mark your destructors as virtual. This is going to save you future headaches you might come in contact with if you are using a base pointer to manage a derived object and you are doing some kind of dynamic memory allocations in your constructors. That's going to release the memory properly if you are releasing the memory through a base pointer like we are doing on line 8 here. This is really all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to learn about dynamic casts. Go ahead and finish up here and meet me there.